Welcome back to the deep end of philosophy, where we are going to crack the code of reality itself. Have you ever wondered how we can claim to know anything for sure when the world around us is constantly changing? Today, we are diving into a dense but incredibly powerful framework for theory that bridges the gap between the messy language we speak and the crystal clear logic required for science. We are basing this on the heavy-hitting ideas regarding canonical notation and the structure of truth, so buckle up, because this is going to change how you see language. Let's start with the difference between speaking and writing. When you speak, you use tense and singular terms that rely on the moment. If I say, "I am hungry now," that sentence is true at this specific moment, but it might be false in an hour. That is a problem for science, because science wants truths that last forever. We call these eternal sentences. Since the invention of writing, there has been a premium on these sentences, because writing strips away the context of the speaker. When you read a scientific paper from 100 years ago, you cannot rely on knowing the mood of the author or the time of day it was written. The writing has to stand on its own. This is why theoretical science pushes for a fixity of truth values. What is true here and now should also be true there and then if we want to discover universal laws. Think about observation sentences. These are things like the litmus paper turned red. That is true, only utterance by utterance. But the theory we project from that data must be eternal. It must stand the test of time. This tendency towards eternal sentences actually simplifies our logical theory. Imagine if the laws of logic had to change every time the wind blew or every time a different person spoke. That would be a nightmare. We assume that if a sentence is true in one occurrence, it will be true in the next. Even a simple inference, like deriving P from P and Q, relies on P meaning the exact same thing both times. If truth values fluctuated constantly, any plan for logic would be unrewardingly complex. Now, you might ask, do we apply logic to changing sentences? Of course, we do. We apply logic to sentences whose truth values vary with time and speaker all the time. But we do this by leaving temporal references unfixed, assuming that the context will settle the matter for the duration of the argument. Occasionally, this fails, and we fall into the fallacy of equivocation, where words change meaning in the middle of a debate. When that hazard threatens, we have to expand the sentences. We do not necessarily turn them into fully eternal sentences, but we expand them just enough to mark the differences brought out by the argument. Think of eternal sentences like silver dollars in our economy. Most of the time, we do not see the actual silver dollars. We just use paper money or digital numbers, but we reckon in terms of them. They are the standard. The primary distinction of an eternal sentence is that it is the repository of truth itself. If a sentence can be said simply to be true, not just true now or true in this person's mouth, then it is an eternal sentence. When our goal is an austere canonical form for the system of the world, we have to be ruthless. We must renounce indicator words like I, here, and now. We must drop the subjunctive conditionals. We have to eliminate anything that causes truth-value fluctuation. Even the word because and similar causal idioms have to go. We strip it all down. Once we set aside propositional attitudes and modality and reduce quotation simply to spelling, what are we left with? We are left with a powerful combination of truth functions and quantification. This is the toolkit used by giants like Frege and Peano to regiment mathematics. So taking this austere approach, what are the basic constructions we have left? It comes down to just three things: predication, hala, universal, quantification, and truth, functions. The ultimate components are variables and general terms. These combine to form atomic open sentences. This gives us the structure known as the logic of quantification, or the calculus of predicates. Now, I want to be clear about something. We are not saying that the idioms we threw away are useless. We need indicator words in the marketplace. We need them in the laboratory. We need them to teach the very terms on which science proceeds. You cannot teach someone what the North Star is without pointing and saying, "Look there." The doctrine is simply that we can abstract a canonical idiom and adhere to it when stating scientific theory. The doctrine claims that all traits of reality worthy of the name can be set down in this austere form. It is a philosophical doctrine of categories. It sets limits on how we derive complex predicates from simple ones. It tells us that whatever is not constructible from our given terms via predication, quantification, and truth functions must either be accepted as a new irreducible term or it must be rejected entirely. This is about drawing a line between what counts as scientifically admissible construction and what does not. Now, let's talk about categories. Some philosophers, like Russell, tried to create strict types to avoid paradoxes. They wanted to say that a sentence like "this stone is thinking about Vienna" is meaningless, or that quadruplicity drinks procrastination is nonsense. But do we really need to ban these sentences? Is it not easier to simply say they are false? Tolerance of the don't cares is a major source of simplicity in theory. If we treat silly sentences as false rather than meaningless, we save ourselves the trouble of building complex categorical fences. We can have a single unpartitioned universe of values for our bound variables. We can admit general terms on an equal footing. Any distinctions we need to make can be drawn based on methodology or natural kind special to the sciences rather than hard-coded into our notation. Now, what about the vocabulary itself? We know one thing for sure. The equal sign or identity will be present. Even if we do not treat it as a primitive term, we can paraphrase it. If we have a finite vocabulary of general terms, we can define x equals y by saying that x and y share every single property. If fx implies phi for every predicate f, then x and y are indiscernible. This imposes a version of the identity of indiscernibles. We call two objects absolutely discernible if an open sentence with one variable distinguishes them. We call them relatively discernible if a sentence with two variables distinguishes them. This is related to Grelling's paradox and Cantor's work. We can always add more terms. However, we can condense terms. If our universe includes classes, we can reduce any vocabulary to a single dyadic relative term. That is a striking, formal condensation. Finally, let's touch on the universe of discourse. When we use quantification, we are assuming a range of values for our variables. What objects count? We do not need to be completely explicit about the total aggregate universe for science. Usually, our quantifications depend only on specific objects that satisfy a condition. For example, when we say all men are mortal, we only care about the objects that are men. The rest of the universe can vary without changing the truth of the sentence. But while we do not need full explicitness, we do need broad normative considerations. This framework of theory helps us organize our knowledge. It separates the subjective, fleeting nature of speech from the objective, eternal nature of scientific truth. It asks us to be disciplined with our language, to strip away the fluff, to focus on what can be quantified and predicated. It is a rigorous path, but it is the path that has allowed mathematics and logic to build the foundations of the modern world. So, the next time you write something down, ask yourself, is this an eternal sentence? Does its truth depend on who I am or when I am writing? If it does, you are communicating, but if it does not, you might just be doing science. Thanks for listening to this deep dive into the framework of theory. Keep thinking and stay curious.